A Saturn-sized planet has been found circling a star so tiny, astronomers never thought it could exist there. It shouldn't be possible, yet there it is, glowing, orbiting, and rewriting everything we thought we knew about how planets form. For decades, scientists believed small stars, especially red dwarfs, could only form small rocky planets. The idea was simple. The smaller the star, the smaller its protoplanetary disk, and the fewer materials available to build a world. Certainly not enough to grow a gas giant. But now, a massive planet, nearly the size of Saturn, has been discovered in a tight, blisteringly fast orbit around one of these faint, lightweight stars. This defies long-standing models of planet formation, and it's forcing astronomers to consider an unsettling possibility. The rules we've trusted may not be universal. This discovery isn't just rare, it's disruptive. The size, orbit, and host star all collide into a perfect storm of contradictions. And with every new data point, the case against conventional planet formation theory grows stronger. Could this be the first of many outliers to come? Or have we just stumbled upon the tip of an invisible iceberg, hinting at an unseen abundance of improbable worlds? The system is known as TOI 6894, located around 240 light-years from Earth. In the constellation Leo, it includes a star that's just 21% the mass of our Sun. This star, a dim red dwarf named TOI 6894, is about 250 times fainter than the Sun. And yet it plays host to something extraordinary, a giant gas planet named TOI 6894b, orbiting astonishingly close to its star. It completes a full orbit in only 3 Earth days. To put that in perspective, Mercury, our own solar system's speedster, takes 88 days to complete a single trip around the Sun. TOI 6894b is moving at breakneck speed. Its proximity to its star means it is almost certainly tidally locked, with one side perpetually scorched in daylight and the other shrouded in eternal night. If you were standing on the day side of this world, the star would loom in the sky, red and massive, casting a dim but steady heat. On the night side, darkness reigns, a deep freeze unbroken by sunrise. The TESS mission, which detected the initial signal, is designed specifically to find exoplanets around bright nearby stars. But TOI 6894's faintness made the detection unusually difficult. Astronomers had to stack weeks of data to amplify the tiny dips in starlight. When the signal finally stood out, the depth of the dip revealed something enormous was blocking the light, far larger than expected for such a star. The study, published in June 2025 in the journal Nature Astronomy, was led by Dr. Edward Bryant at the University of Warwick in the United Kingdom. His team included Dr. Vincent van Eilen, an expert in exoplanet statistics from University College London's Mullard Space Science Laboratory. Together they confirmed that TOI 6894b is not only larger than expected, it orbits the smallest star ever known to host a giant planet. The discovery flies in the face of decades of planetary theory. Dr. Bryant explained the shock of the finding simply: the question of how such a small star can host such a large planet is one that this discovery raises, and we are yet to answer. The scale mismatch isn't just unprecedented, it's deeply problematic for current simulations. No formation pathway we know should allow a planet of this size to grow in such a barren environment. According to existing models, planets form through a process known as core accretion. Dust particles in a protoplanetary disk stick together, gradually growing into pebbles, then planetesimals, and eventually into a massive core. If the core grows fast enough, it can begin attracting a thick envelope of gas before the young star's radiation blows the disk away. But here's the problem. Red dwarfs like TOI 6894 are so small and cool that they shouldn't have enough material in their disks to allow a gas giant to form at all. And yet, TOI 6894b exists. Not only is it there, it's huge. Just slightly larger in radius than Saturn, with about 56% of Saturn's mass. That gives it a relatively low density, making it puffy and light for a gas giant. What's more striking is the size comparison between the planet and its host star. While our Sun is about 10 times wider than Jupiter, TOI 6894 is only about 2.5 times larger in diameter than its own planet. No planet has ever been discovered that's larger than its host star, but this one comes dangerously close to that boundary. It challenges the very limits of how we define a solar system. The visual scale is almost surreal, a planet nearly rivaling its star in size, locked in a gravitational embrace that defies textbook physics. The tidal interactions between such closely matched masses could even create internal friction within the planet itself, potentially puffing it up and sustaining its inflated radius. Dr. Van Allen noted the sheer improbability of this. In small clouds of dust and gas, it's hard to build a giant planet. To build a giant planet, you need to quickly build a large planet core and then quickly accrete a lot of gas. But there's only so much time to do it before the star starts shining and the disk rapidly disappears. So, how did TOI 6894b form? That question is shaking up the exoplanet research community. One possibility is gravitational instability, where chunks of a gas cloud collapse directly into a planet without going through the core accretion process at all. Another is migration. The planet may have formed much farther out in the disk, where conditions were more favorable, and then spiraled inward over time through gravitational interactions. Or perhaps the traditional models just don't account for rare but extreme cases like this, cases that we've simply missed until now. TOI 6894b may even be part of a larger unseen system. The research team is planning further radial velocity observations to search for any additional smaller planets that may be tugging on the star from more distant orbits. The presence of companions could help clarify whether TOI 6894b arrived via migration or formed in situ. The researchers used high-precision spectroscopic data to estimate the mass of the planet and confirm its low density. Combined with the TESS light curve, the result was a complete picture of a system that just shouldn't exist. And yet, it's there, real, measurable, orbiting every 72 hours. Dr. Bryant believes the key to understanding this anomaly may lie in the planet's core. He said, "We expect it to have a massive core surrounded by a gaseous envelope made up of predominantly hydrogen and helium gas. That core could provide clues about how such a planet was able to form in a disk that should have been too small and too poor in material to support such growth." The implications of this discovery ripple far beyond a single planetary system. If a red dwarf this small can host a gas giant, what else might be out there? Red dwarfs are by far the most common stars in the galaxy. They make up roughly 75% of the stars in the Milky Way. If even a small fraction of them can host giants like TOI 6894b, then our assumptions about the rarity of such systems might be wildly off. This also forces a rethink of how planetary systems evolve. If giant planets can exist around tiny stars, then their gravitational pull could dramatically reshape the architecture of surrounding worlds, potentially ejecting smaller planets or shepherding them into different orbits. That has implications for habitability as well. Nearby rocky worlds, if any exist, could experience tidal heating, radiation, or even orbital destabilization due to the presence of such a close-in gas giant. And then there's the question of what else we've missed. TESS has only surveyed a portion of the sky. The James Webb Space Telescope is expected to follow up on TOI 6894b soon, analyzing its atmospheric composition and structure. It may confirm whether the planet formed with a heavy core or whether some other mechanism was at play. The discovery also opens the door to new observational strategies. Previously, astronomers avoided looking for giants around small stars because the odds seemed too low. But now, with TOI 6894b breaking the mold, those odds must be reconsidered. Perhaps the cosmos is telling us to widen our gaze. And perhaps we've underestimated the creative chaos of planetary formation itself. Maybe nature doesn't care about our models, only about what's possible. And in that possibility lies the future of exoplanet discovery. TOI 6894b is more than a gas giant. It's a challenge, a question mark. A planetary monarch orbiting a star barely capable of kindling its own light. It shouldn't be there, and yet it is. Sometimes the universe throws us something so unexpected, it rewrites the rulebook in a single stroke. That's the beauty of science. Every answer raises new questions. So, is this just the first of many hidden giants, or the rare survivor of an impossible birth? The truth is still out there, waiting to be found. Subscribe for real science, updated daily from peer-reviewed studies across the globe. Because the universe never stops surprising us, and neither should you.